Looking at some special cases when we're factorising cubics, and the special case we've got here, x cubed minus 27. From our previous work we know that when p of alpha is 0, x minus alpha is a factor. So we can see that we've got x cubed minus 27. So c is negative 27, and here we can see from our previous video, I'm showing you again where alpha is as in x minus alpha. Alpha divides c, but and alpha is a factor of c. So let's have a look at that for this question we're doing. So since c equals negative 27, okay, it's still the c term despite the fact that you can't see any x squared or x terms. It's still a cubic polynomial, so that's still the c value on the end there. Okay, so don't be put off by the special case. It's still quadratic, cubic polynomial. So we look for, we go through them and we look for the value of alpha that will make p of alpha equal to 0. And with a bit of trial and error using these here, we find eventually that to save a bit of time, when alpha equals 3, we have p of 3, and we have 3 cubed, take 27, and that does equal 0. So that means alpha is 3, and we have x minus 3 as a factor. Alrighty, so we're ready to start, so we can divide this through. Now put some placeholders in would be my recommendation, very much. So I've got some placeholders in there, and we have our x minus 3 now as our factor. So I've gone through and completed that nice and quickly. Just a moment ago I just made a correction there. That was written in as a plus before, it's minus there. So we get a quotient up the top there. Okay, written in factorised form, we can see that there. And with this quadratic part, we can't factorise that any further. So this, if this was an equation, this would only have one solution. It's got one root. Okay, so 2 factors, 1 root. This result shows an important pattern, and this is the special case we're talking about in this video. So if you have x cubed minus a cubed, x cubed minus a cubed, which has a special name, it's called the difference of 2 cubes. Called the difference of 2 cubes because you have one cubed thing minus another cubed thing. And if we use the generic symbols x cubed minus a cubed, where a is an integer, we get this pattern which you should know, and the question just did demonstrated that. So it's x minus a times x squared plus ax plus a squared. Okay, so x cubed minus a cubed equals x minus a times x squared plus ax plus a squared. So that's an important result. What if we had x cubed plus a cubed? It looks similar, doesn't it? So basically this would be like if we replaced a with, in the previous identity up here, if we said if we had x cubed minus negative a cubed. That would be x cubed. Now, negative a cubed is negative a. So, because negative a squared is positive a squared, negative a cubed is actually a negative quantity. So that would become out as the negative, or negative 1 times a cubed, and minusing a minus is plussing a positive. So we have that there. And so that's what we're doing. We're replacing a with negative a. Alright, so, and it gives us that pattern there. So back to what we were doing. That was just a little aside there. So basically, if we replace it with negative a, and we use that in the above pattern, we'd have a being replaced by negative a. I've just written it down a bit lower because of the room it takes. So that'd be x plus a, x squared minus ax plus a squared. So that's our second result. So it's x cubed plus a cubed equals x plus a times x squared minus ax plus a squared. So that's the second important result there. So that's like a shortcut if you see that pattern, the difference of two cubes, or this one, which is the sum of two cubes. It's just another version of the difference, really, isn't it? Sum of two cubes. You can actually shortcut it and factorize it if you know that. It's a bit like the difference of two squareds with quadratics, which you should know too. So if we had to factorize x cubed plus 64, instead of going through factorize, instead of going through this above procedure where we've got to, do this and then find and then divide through, if you just cite the difference of, or sum of two cubes, which is what we got, and just apply the formula. So that is the sum of two cubes. And what would a be? Or an x. So x would be corresponding with, x cubed would be corresponding with 8x cubed. So that means x in the pattern corresponds with 2x, because that is there 2x all cubed. Okay, remember your index laws. And a cubed is corresponding with 64. So a would correspond with 4. So following the pattern, we've got, instead of x plus a, we've got 2x plus 4. And then instead of x squared, we've got 4x squared minus 4 times 2x, which is 8x. Instead of x squared, we've got 16. So that's a shortcut to factorize that special case cubic.